Hello everyone, my name is K. Rajesh. I am from CSC B section. Today's my topic is about software engineering anti-patterns in startups. Introduction. Software startups are important suppliers in innovation and software intensive product and services. There has been a steady growth in capital invested with 2017 settings a record of 16 billion EUR invested in European startups. However, only a few percent of startups manage to deliver any value. Thus, a significant capital is wasted on building unsuccessful products. On a surface, the low success rates can be explained by market challenges, the difficulty in attracting customer interest, and resources shortages among others. However, digging deep, we found indications that the capability to build software efficiently with minimal resources and limited knowledge about emerging target markets is the foremost challenge in software startups, and this is the large extent closely related to engineering practices. If even only a small part of a startup's failure can be attributed to failures in the actual engineering practices and principles applied in the translates into a significant loss of investment. Very little is known about software engineering in startups, and to what extent the lack of customer interest and resources overruns and related to deficiencies in engineering. Earlier studies suggest that uh, scoping and building a minimum variable product is a sustainable challenge and precedes any market or business related challenges. Thus, failure in engineering could hinder any subsequent attempts to market the product and to build a sustainable business around it. Startup engineering anti-patterns. Our analysis shows that startups experience different challenges depending on how far into production development they are. From the reports, we identified three phases in startups uh, progression categorized by specific goals and challenges. Phase 1 is considered with building and realizing the first release of a product. Phase 2 is concerned with attracting first customer to the product beyond unknown early adopter and data testers. Phase 3 is concerned with scaling the product further into new markets. As, as illustrated in Figure 2, the report suggests three distinct progression phases, each with the specific aim and symptoms of the anti-patterns. The plotted line represents the expected growth of the company. The forks denote alternative sceneries, that is anti-patterns that could hinder the progression of the startups. Along with the causes at the bottom of the figure, we denote how many reports were the basics for identifying each cause. In the figure shows the startup milestones and symptoms for anti-patterns. Here in this image we have three phases: phase 1, phase 2 and phase 3. In phase 1, build the first version of the product, and in phase 2, attract customers interest to the product, and in the third phase, grow into new markets. Anti-patterns 1, not releasing a market worth product. The reports suggest that one of the initial engineering challenges is to build and release the first version of the product, the minimum viable product, bare bones version of the product, good enough to be used in the for its main purpose, and to test if there is enough customers interest to satisfy further investments in product development. With the advantage of insights, the startups emphasize the importance of small and fast to develop a first release of their products. However, some startups reflected that It took them a overly long time to build the first version, structured resources, and drained motivation, which cost them the most opportunity. Symptoms and outcomes of anti-patterns 1 are illustrated in figure, and figure 3 shows the breakdown of anti-pattern 1. Reflections in the reports suggest two main causes for the anti-patterns. Cause 1, design decisions, see figure 3, is concerned with selecting technologies and components that constitute the product. The choice lies between developing features in-house, utilizing open source components, or buying certain functionality for the third-party suppliers. In their reports, startups reflect that building commodity features that can be obtained by other means was a waste of significantly prolonged product development. Furthermore, the quality of in-house development features was often significantly lower than the alternative regarding functionality, performances, and maintainability. Anti-pattern 2, attracting customers. The report from a startup and that have launched their products suggests that the next challenge is to bring the product to market. While coordinating markets and sales activities are important to attract customers, the companies reflect their characteristics of the product stemming from earlier engineering decisions, hindering their marketing activities. Here is the image shows the breakdown of anti-pattern 2. The analysis of the reports shown three potential causes. See figure 4 that could hinder efforts to market the products. The most common symptoms is the difficulty to find potential customers and convert them into paying customers. Reflections in the report suggest that lack of customer involvement at the right level in developing the product. Cause 1 largely contributes the marketing issues later. We identified two related sensors. The first is that customers are not involved in requirements, elections, and validation, and the product turns out to be irrelevant to market. Analysis of causes. Speed is one of the most praised startup advantages over larger companies. However, the startups can build itself into a corner by accumulating technical debt. Technical debt slows down development of new features, introducing hard to address quality issues, and degrades terms morals. Unwanted technical debt seeps in due to poor engineering decisions, sloppy individual attitudes, and insufficient coordination of engineering work. Functional errors, suggestions, and unexpected app crashing are the most common among customer complaints. Such results suggest the engineers should pay extra attention of removing any such issues from the software before releasing it to the public. Anti-pattern 3, a good problem to have. Startups that had attracted and subsequently number of customers reflect on challenging concerns growth beyond their initial markets. At this stage, markets startups reports a declining customer satisfaction, difficulties expanding into new markets, and high operational costs hindering sustainability of the company. The outcomes of these anti-patterns are difficulties establishing a sustainable business model and growth issues. Here is a image shows the breakdown of the anti-pattern 3. The reports discuss declining customer satisfaction. Cause cause 1 is association of startups undertaking tangent projects and focusing efforts to enter new markets. Such activities could take attention and resources of existing customers and hindering their satisfaction. The root cause of such a scenario is the lack of organizational framework supporting growing number of customers continue to develop the product and to expand. According to the reports, another common challenge is to expand into new markets. Part of the difficulty is to conduct sales and marketing activities over a geographical distance. However, another part of the challenge cost too is to identify the what are the differences in customer requirements between markets and tweak the product production from the new market. Cost 3 is hindering startups at this stage. It cope with high production, operational and maintenance costs. The increasing costs are associated with extra framework and computing power requirements to serve the increasing number of users. When costs grow larger than actually value provided by the product, the business model of the company cannot be sustainable. Conclusion: the analysis of the startup experience reports shows as the association between shortcoming in software engineering practices and principles and startup failures. The association highlights the importance of the using good software engineering practices in startups. However, improving engineering practices does not necessarily mean spending more time and resources on engineering works. Timely and efficiently addressing root cause of the potential problem down the road uh, could save resources. Thank you.